Hey everyone. So in today's lesson, we're going to deal with the surface area and volume of two more shapes that have kind of connected to each other, the sphere and the hemisphere, okay? We're gonna deal with spheres first. So a sphere, you guys would know that as a ball essentially, but it's the set of all points that are equal distance from a fixed point, okay? So that fixed point is the center of the sphere. And then you're familiar with circles that would have a radius. Well, with a sphere, essentially that radius can go in any direction, okay? And it always points to the outer edge of the ball, and that's what makes the sphere. Now, there are formulas for the surface area of a sphere and the volume of a sphere. I'm going to show them to you. There's actually two sets, one whether you're dealing with the radius or one whether you're dealing with the diameter, okay? So surface area is 4 pi r squared for the surface area if you're talking about the radius, or pi d squared if you're talking about the diameter. And then the volume of the sphere would be 4/3 pi r cubed. And then if you're talking about the diameter, you could use 1/6 pi d cubed. They're the same formula, it's just whether you want to deal with the radius or whether you want to deal with the diameter, okay? So what we want to do next is I just want to show you a quick interactive video on how we derive that formula for the volume of a sphere, okay? And you need to use the surface area formula, which I'll show you in a second. But essentially, again, I know I said this in a previous lesson. I do these things because I want to make sure you guys realize nobody just sits there and says, oh, this looks like a good formula, let's just make this up and make kids do it, okay? Everything derives from something. So this is an interactive video that your textbook has an online version, and this is available in the online version. So I'm gonna play it for you, and I'm gonna pause a couple of times through it and just help you understand what's going on, but I want you to have that visual, okay? So here it is.
We can use the formula for the surface area of a sphere to develop a formula for the volume of a sphere. Visualize a sphere covered with very small quadrilaterals. Each quadrilateral is joined by line segments to the center of the sphere to form a pyramid.
Okay, so just to clarify there, see, what we've done is we've taken the surface area and we've made a quadrilateral just means a four-sided figure, okay? So we covered that surface area with teeny tiny quadrilaterals, and then we connected all corners of the quadrilateral back to the center of the sphere. What that will do is create a pyramid, okay? Now, we know how to get the volume of the pyramid, okay? It's 1/3 base area times height. So the volume of the sphere will become the volume of all those pyramids added together, and that's what she's gonna say here, okay?
The volume of the sphere is the sum of the volumes of the pyramids. We know that the volume of a pyramid is equal to 1/3 the base area times the height of the pyramid. The height of the pyramid is the radius of the sphere, so we can replace height with r.
Okay, now think about the sum of all the base areas. This is covering the sphere. Well, the sum of all the base areas then is actually the surface area of the sphere, and you know the surface area of the sphere. We just talked about that. It was 4 pi r squared, right? Okay.
Since the bases of the pyramids cover the surface of the sphere, the sum of all the base areas is the surface area of the sphere, 4 pi r squared.
Now, you just need to do a little bit of math. You know that 1/3 times 4 will be 4/3, and you know that r squared times r will give you r cubed, okay? And that's where the formula is going to come from.
So, the volume of a sphere is equal to 1/3 times 4 pi r squared times r, or 4/3 pi r cubed.
Okay, so let's now turn our attention to a hemisphere. A hemisphere, hemi, in Latin means half. So a hemisphere is literally a sphere that's been cut in half, okay? Now, one of the things I need you to know right away is we don't give you formulas for the surface area and volume of a hemisphere. we expect that you understand how to derive those from the formulas that we give you from the sphere, okay? Now, the volume one is super easy because you just take the formula for the volume and you cut it in half, okay? So some kids like to actually find the volume and then they take that number and cut it in half. As a formula though, the other thing you could do is think about that 4/3 that's at the beginning of your volume for your sphere formula. If you change that to 2/3, that is now half of what it was, okay? So the volume of a hemisphere is 2/3 pi r cubed, okay? Now, here's the thing about the surface area. Remember that we said that the surface area of the whole sphere was 4 pi r squared, okay? So one might say, okay, well, I'm gonna cut that in half and that'll give me 2 pi r squared. And you're right to one extent, but here's where you have to be careful, okay? That 2 pi r squared would be this outer edge here, right? But what I want you to see is when you sliced it in half, you created this other surface, and that other surface is actually another circle. So a circle is pi r squared. So when I put all that together, I'm actually going to end up with 3 pi r squared for the hemisphere, okay? And that's the one that's not given to you because we want you to understand where it came from, okay? And then the volume I just talked about, that was the 2/3 pi r cubed, okay? So here we go. A soccer ball has a diameter of 21 centimeters. Calculate the surface area of the ball to the nearest tenth. So like in every other question we've done, we're going to start by writing out our formula. We're looking for the surface area. I chose to use the pi d squared one because I was given the diameter. Alternatively, you could have used the 4 pi r squared one and called the diameter, or sorry, called the radius 11.5. That would have been fine. The exact same answer will come, okay? So don't get stressed over which one to use. Use whichever one makes the most sense to you. So I plugged in 21 for D, and that's gonna give me 1,385.4 centimeters squared. I've rounded to the nearest tenth. I've made sure my units were centimeters squared. I'm good to go, okay? The surface area of a lacrosse ball is approximately 20 square inches. What is the diameter of the lacrosse ball to the nearest tenth of an inch? Okay, so we're talking about surface area. I know what the surface area is and I'm being asked for the diameter, so I'm gonna again use the surface area equals pi d squared formula because that's gonna give me out the diameter. I know the surface area, so I replace surface area with 20. And now I need to solve for d, so I'm gonna divide both sides by pi, and then I'm gonna square root it, so I get d all by itself. And that's gonna give me 2.5 inches, okay? 2.5 inches. Okay, the circumference of a beach ball is 55 centimeters. Find its volume to the nearest tenth. Okay, so I know the circumference. So I do have a formula way back in the back of my head about circumference. I don't know if you had it way back in your head or not, but circumference is, to the circumference is, that's enough to give me the radius. I'll have to divide both sides by 2 pi. Remember to either put 2 pi in brackets if you're a TI kid, or make sure you have a fraction button open, okay, if you're a newer model. Okay, so R is going to be 8.75352187. Please take note. I'm trying to give you a bunch of decimals there so we don't run into any rounding error. Never round to that nearest tenth until it's your absolute final answer, okay? It will throw your answer off, just like using 3.14 for pi would throw your answer off. Make sure you're using your pi button, okay? And so that no rounding should be happening until the very last of the answer. So now I'm looking for the volume. So the volume would be 4/3 pi r cubed. When I do this, I'm actually gonna go 4 divided by 3 times pi times answer cubed, because that answer is sitting in my calculator right now. And that way I don't even have to write down all of those decimals, okay? I'm using my calculator to my advantage there so I don't run into any rounding error, okay? And then that's gonna give you 2,809.6 centimeters cubed. 2,809.6 centimeters cubed, okay? All right. A hemisphere has a radius of 5 centimeters. So take note that we've changed it. We're not talking about a sphere anymore. We're going to talk about a hemisphere. Determine the surface area of the hemisphere, to the nearest tenth of a square meter. Okay, so I know that the surface area is 3 pi r squared. And we talked about why it's 3 pi r squared, right? When we cut it in half, we have 2 pi r squared on the bottom, but then we created that circle surface on the top, okay? Okay, so I know the radius is 5, so I plug that in and plug it into my calculator, 235.6 centimeters squared. 235.6 centimeters squared. Now calculate the volume to the nearest tenth. Okay, so volume will be 2/3. Notice that the volume of the sphere was 4/3. So I've changed my 4/3 to 2/3. That's essentially cutting it in half. Okay, so 2/3 pi r cubed. I throw in my 5 for my radius. And again, when you're typing this in your calculator, you can type that as a fraction if you want. If you have a newer model calculator, you can just open up a fraction button and do that. It's probably just as easy to just go divide by 3 though as well, okay? Either way, you should get an answer of 261.8 centimeters cubed when properly rounded, okay? All right, so that's your homework for this lesson. Again, make sure when you're communicating your work to me that I need to see the formula you're using. I always need to see what you're subbing in for what variables, and then I need to see your work on how you're solving to the unknown variable that you were being asked to solve, okay? Connect with me if you have any questions, and then we'll see you next time. Next time we're gonna talk about composite objects, and that'll be the last lesson of this unit, okay? Take care, guys.